differs from the previous two exercises is the following. It doesn't undergo any acceleration change. Do you see the way the acceleration remains constant all the way through? Okay. The next thing about this question is it's only one vehicle. It's not two vehicles, it's one vehicle. That's going to be a common theme in this full exercise. One vehicle, constant acceleration. Everybody got that? Or one object, constant acceleration. One object, constant acceleration. That is how I'd summarize this exercise. Okay. Next thing. When you're on this, you're going to put a start and an end point. So here's your start, here's your end. And en route, you're going to go by different markers. Okay? So it passes point P at speed. What does that speed mean? It has an initial velocity u. U is bigger than 0. Agreed? Then it keeps going. And what happens then? 2 seconds later, it travels how far?
80 meters.
80 meters. And that is t equals 2. Now, and in the 2 seconds after that, it covers a further 30. So what does that mean? An extra 30 meters and t equals 4. Now we're going to use UVaster, right? And I'm going to name these two things. So I'll just go alphabetical. I'll just call it P, Q, R. Is that okay with you guys? P, Q, R? Now, yes.
How do you know?
It's in the question, if you read it. Yeah, 2 seconds to cover the first 18 and another 2 seconds after that to cover another 30 meters. Okay, so that's why I added it. Okay, now what you're never ever ever to do is this. I'll show you what you're never ever to do, right? So I'm going to do PQ and I'm going to UVAST it. U-V-A-S-T. What happens when you UVAST it? What you get? What's U? Is U. V? We don't know. A is the goal of the question. S is what? 18. I'm doing P to Q. Sorry, that looks like an R, you're right. I'm actually doing P to Q. Is that okay? P to Q. So it's 18. Time value? 2. About to make a mistake here. QR. What's the U value of QR? What speed is it going as you cross the line here? You don't know, do you? I don't know how fast that's going, do I? It's actually equal to the V of the last question. Of the last part. But I don't know it is the answer. Okay? V, I don't know. A is still A. S is what? And T is 2. And guess what? You're lacking a variable on your second data set. Agreed? So here's how we solve this problem. We never, ever, ever take a middle part. I will never take Q to R. I instead will take P to R. And I'll reset the data. And you'll see it'll come out a lot better. Okay, that's the key to these questions. Never, ever, ever take the middle section. Always take common starting point. PQ, PR. The next one we're going to do is going to be PS. I won't be taking RS. I'll be taking P to S. Agreed? Here we go. What's the U value now? It's also U, because you're starting at P both times. Your A value is still A. Your S value? 48. And your T value? 4. Now you stop there and you go, okay, I got 2 data sets now. What formula should I use? Well, we're going to have to use a formula involving S. So what are your options? UT plus a half AT squared, or V squared equals U squared plus 2AS. Which one do you think is the appropriate choice and why? been told that S equals ut plus a half at squared is the appropriate choice. Reason being, we want to avoid the v values that we do not know or have. Yes.
We don't know what U is had.
Yes, but it's the same u value both times. Well, if I use v, that v is different from this v. So there's a common u value at least. That's what we're getting at. Now, let's start off with the first data set, which is the first data set has the 18. So you go 18 equals u times t. What's that then? Plus a half at squared. Plus a half at squared. So it's going to be a times 2 squared. And then you have 18 equals 2u plus 2a. And that there is half a simultaneous equation. Agreed? Half a simultaneous equation. Then we're going to go over to the other side. And we're going to do the exact same thing, except this time it's 48. So I use different color. This time it's 48 meters covered in 4 seconds. And then 48 equals 4u plus 8a. And then we're going to solve these simultaneous equations. I'll just double the u value. I'll double the blue equation. So I'm just going to double the blue equation. And I'll probably, and minus 2 actually, yeah. So minus 36 minus 4u minus 4a. 4a equals 12. 3 equals a. A is 3. ms squared. And then I'm going to sub in that 3 up here. And that means 2u must be responsible for 12, because 12 plus 6 is 18. So I'm going to get 2u equals 12, and that puts my u value at 6, solving the simultaneous equations. Now, what it then asks me is, it goes, if it traveled another 2 seconds, how far is this green distance here? Everybody see that green distance? Well, for me, that green distance is the same thing as this yellow distance subtract 48. Does everybody get that? The green distance is the same as the yellow distance, take away 48. Because you cover 48 before the green distance. Is that alright? So I'm going to do P to S. That's P going all the way to S. And then I'm going to subtract 48 at the end. And that'll tell me how much extra distance I covered. So quite literally, I'm using the same UVasts. What is going on here? I'm using the same UVasts I used the last couple of times. Okay, let me see if I can do this. So it's UVAST again. U value is what, guys? 6. V value? We don't know. A value? 3. S value? That's the goal of the question. T value? An extra 2 seconds? 6. S equals UT plus a half AT squared. Okay, and what do we get? 6 times 6 plus a half. 3 times 6 squared. I think it's 54 plus 36, which is like 80, and then a half of that is 40. Oh, sorry, no. I'm wrong. 90. 90? 90, sorry. So S is 90. I had to get an answer bigger than 48. Why did I have to get an answer bigger than 48? I was going to subtract the 48 from it, so if it was smaller than 48, I was in trouble. Subtract 48, and what do we reckon? 42 meters. Does 42 meters make sense? Does it make sense for the last section to be 42 meters? you're going faster. Think about it. You start off at You start off at a speed 6 and you're going at acceleration 3. As time expands, you're going faster and faster and faster and faster. It's like being on the dart. You go really slow through the first 2 checkpoints, and then by the end you're going really fast through the checkpoints because you're going much faster, aren't you? That's the way that'll work.